Hi everyone. Today we are going to learn about semi-group and monoids in mathematical foundation of computer science. So let's jump right in and explore these cool maths concepts together. So what is a semi-group? A semi-group is a set with a binary operation, maybe addition or multiplication, that is closed and associative. So let's discuss about properties of semi-group. For an algebraic structure to be considered as a semi-group, it must satisfy two main conditions: closure and associativity. Closure. Closure is nothing but a combination of any two other elements in a set results in another element within the same set. Associative. Associative is allowing for grouping which of elements without affecting the final result. So let's discuss about what is a monoid. A monoid is a semi-group with an identity element that leaves any other element unchanged when combined with it. So an algebraic structure is said to be a monoid if it satisfies three conditions: closure property, associative property, identity property. So if we compare semigroup and monoid, semigroup consists of set of and a binary operations that satisfies the associative property but do not necessarily have an identity element. Monoids. Monoids are a special case of semigroups where the set of elements also contain an identity element that leaves any other element unchanged. The relationship between these two are every monoid is a semigroup, but not every semigroup is a monoid. Monoid adds the additional requirement of an identity element to the semigroup structure. So, when we discuss about applications, semigroup and monoids have a wide range of applications in various fields, from computer science and mathematics to linguistics and beyond. So, let's solve some problems. Just a second. So, the first problem is prove that set of whole numbers forms a semigroup. Here, W represents a set of whole numbers. W equals to 0, 1, 2, 3, and these are the elements of set of whole numbers. So to prove any set is a semigroup, it should satisfy two conditions: closure, associative. So let's start with closure. So the sum, let's take some examples. So here the sum of 1 and 2 is 3 and 3 belongs to the set of W. So closure property is satisfied. Let's take another example. 7 plus 8 equals to 15. Here the sum of 7 and 8 is 15 and 15 belongs to the set of whole numbers. So closure property is satisfied. Now let's talk about associative. So here, let's take some examples like 1 plus 2 plus of 3 is equals to 1 plus of 2 plus 3 equals to 6. So it satisfies the associative property. Let's take another example like 7 plus 8 plus of 9 equals to 7 plus of 8 plus 9 equals to 24, and it satisfies the associative property. As it satisfies all the conditions of semigroup, we can say that set of whole numbers is a semigroup. Now let's take some other example of monoid. Show that the set of integers under multiplication is a monoid and find the identity element. Here Z is the set of whole integers and -2, -1, 0, 1, 2 and so on are the elements. So to prove any set is a monoid, it should satisfy three conditions: closure, associative, identity. Let's start with closure. Let's take some examples like the product of -2 and 1 is -2 and -2 belongs to the set of V. Closure property is satisfied. And associative. 1 into 2 of into 3 is equals to 1 into of 2 into 3 equals to 6. So associative property is satisfied. Now when we talk about identity property, the product of -2 and -1 is -2 and -2 is given as an operand and the element is unchanged. Let's take another example like 4 into 1 equals to 4. The product of 4 and 1 is 4 and 4 is given as an operand and the element is unchanged. As it satisfies the identity element and identity property. So the identity element is 1 and it satisfies the identity property. As it satisfies all the conditions of monoid, we can say that set of integers under multiplication is a monoid and the identity element is 1. So we have solved two problems based on semigroup and monoid. Thank you.